Hello, welcome to this 8051 microcontroller series. Today I am going to explain you the register banks which is used in 8051 microcontroller. Myself Dr. Aditya Nehra. Before going to the details of the register banks which are used in 8051, we must know the RAM organization in 8051. There are two types of memories in 8051 microcontroller, that is RAM memory and ROM memory. ROM which is of 4 KB and RAM which is of 128 byte. So we will discuss the 128 byte of RAM organization, how it is organized. See, this is the structure for the RAM memory. It is divided into the first part. The first part for register banks, bit addressable memory location and stack and scratchpad memory, and second part that consists of the SFR, that is nothing but the special function register. Only 21 addresses in SFR area can be used in this microcontroller. Okay, so we will see the detailed structure of RAM organization. See, here it is. If you see this, the structure, the memory address that starts from 00 and it will end to the 7FH. As I explained you that it consists of the 128 byte of RAM. So how we can how we can find out the address of it? So 2 raised to 7 which is equal to 128. So 7 bit of address is used for this. So starting address of this RAM memory organization is for 0000 to 7FH. This is the range for the memory. This indicates the address of the RAM. In this, lower 32 byte that is set aside for the register banks, and above that 16 bit of this that is assigned for the bit addressable area, that is nothing but we can assign the address to the single bit only, and above that 80 byte that is for the general purpose area. For the different mathematical operations we can store that information to this general purpose area. So this is divided into, the total 128 byte is divided into 32 byte of RAM, 32 byte of RAM, 16 bytes of bit addressable memory and 80 bytes of general purpose area. So we'll see the detailed structure of this. See, here it is. 4 register banks are here. According to this diagram, according to this diagram, the address for this register bank, it will start from 00 to 1FH. There are 4 register bank for this. Register bank 0, register bank 1, register bank 2, register bank 3, each of 8 byte. Means, see, if we see the register bank 0, it consists of the register from R0 to R7 and each register which is of 8 byte. Since what we can say here, the 8 byte for register 0, 8 byte for register 1, 8 byte for register 2 and 8 byte for register 3. So total 32 bits are allocated here. So how we can give the address to this? See, it is from 0. So R0 is for 0th memory location for bank 0. Now next is address is 01, that is for R1, that is of 8 bit. 2, that is for R2. The memory location 3 is for R3, memory location 4 is for R4, memory location 5 is for R5 and memory location 6 is for R6, memory location 7 is for R7. So this R0 which is of 8 bit register, R1 which is of 8 bit register, all register which is of 8 bit. So what we can say, the bank 0 which consists of the 8 register which is of 8 byte. So this bank 0 is for this bank 0, 8 byte of memory location is allocated. Afterward, the next, the position, address position of 08, that is assigned for register R0, but that is for the bank 1. It is shifted to the bank 1. For bank 1, 09 location is given for register R1. In this way, up to 0F memory location, the 8th register R7 is used for register bank 1. For register bank 2, the starting address is 10 and it adds up to 1 7. This consists of the 8 register from R0 to R7, each of 8 bit. After that the bank 3, which consists of the memory address 182 1FH, and it again consists of the 8 register each of 8 bytes. So what we can say, the memory location from 00 to 1F, that is total 32 bytes, are assigned for the 4 register banks. Now how we can use these register banks? We can use this register. By default, register bank 0 is set when 8051 is powered up. But suppose you want to use the register bank 1, register bank 2, register bank 3. In that case, you have to use the program status word register. That program status word register, which is of 8-bit register, the structure is shown here. It consists of the 8 bits, in which 7 bits are find out, and 1 is undefined. So program status word 0, which consists of the parity bit, overflow bit, RS0, RS1, F0, flag bit, auxiliary carry flag, and the carry flag. Okay, so R0 and R1, which stands for register bank select bit 0, RS1, which stands for register bank select bit 1. What this indicate? If suppose you want to use the register bank 0, in that case you have to set this bit position of PSW.3 and PSW.4 to the 0th memory location. So it will set the register bank 0. If suppose you have to use in the program register bank 1, then you need to set here RS0 bit to 1 and RS1 bit to 00. So 0 1, it will set the register bank 1. For register bank 2, RS1 is set to 1 and RS0 is set to 0 0. And for register bank 3, both RS0 pin and RS1 pin is set to 1 1. And for this purpose we have to use the instruction set bit. So here it shows the set bit PSW.3. What this instruction indicate here? Set bit means it will set to 1. It will set to 1. So program status 1 3 is, that is PSW3, that is nothing but the bit RS0, that is set. So RS0 is 1. What this indicate? Register bank is selected. So we can use that register bank 1 for the particular application. See here it is. These commands are shown how it is used. Set bit for setting the PSW4 and PSW.3 bit. Set bit, we can directly set PSW.3. For clearing the bit, that is it will set the 0. So clear PSW.3, directly it will be indicated here. Okay. Now bits D4 and D3 of PSW are used to select the desired register banks. You need to remember this point, and we can use the set bit and clear instruction to set and clear this register bank. Now how we can store the information? Some examples are given here. The first example is move R1 comma hash 99H. What this indicate? By default, as I explained you, by default 8051 memory bank register bank 0 is set. So it will set the memory location 01, and at this memory location this 99 value is stored. This is of 8-bit information. If we see the second instruction, move R4 comma hash 25. What this indicate? 25 value is stored in the memory location R4. So what this indicate here? The 04 is the address of this R4. So 25H is stored at this 0th memory location. Okay. After that, the third example, what it indicate? Move 18 comma hash 56H. What this indicate? The value 56H is stored at the memory location 1A. So instead of using the register, we can also give the address to this, and to that particular address the value will be stored. So in this way we can use the register banks. Now next memory bit position is assigned for the bit addressable area. Now what this bit addressable area indicate? We can access the particular bit, and for the particular operation we can store the single bit. And see here it is, each bit consists of the separate address. So what is the starting location for this? It is for address of this bit location is for 2022FH, and each 20 memory location which consists of the 8 byte we can store here, 8 bits we can store here. For 21 memory location we can store the 8 bits. For 22 memory location we can store the 8 bits. So total of up to 2F the 8 bit memory locations are stored here. So what we can say, each bit position consists of the different address, and that addresses is from 00 to 7F. Okay, so from 20 to 2F total 16 byte area is allocated for this bit addressable memory. So this is the RAM organization and the different register banks we can use for the 8051 microcontroller.